Hello everyone, today we completed the core deployment of OpenClaw on the Jetson platform. The entire process is very clear. I will guide you step by step through the operation. In this step, we first install NVM using a single command. NVM is a Node.js version manager, and we use it because it allows us to easily switch between different Node versions across projects, helping us avoid environment conflicts. After the installation is complete, we run source/bashrc to make the configuration take effect immediately. Otherwise, the current terminal won't recognize the NVM command. Next, we use NVMV to verify that the installation was successful. If a version number is displayed, it means NVM is working properly. Then, we install Node.js using NVM install 22. Compared to installing Node through the System Package Manager, this method is cleaner and much easier to manage. After the installation, we run NVM use 22 to switch to the Node version we just installed, ensuring that all subsequent operations use this environment. Finally, we set it as the default version, so every time we open a new terminal, this Node version will be used automatically without needing to configure it again. At this step, we first verify whether Node.js and npm are installed correctly by checking their versions. If both commands return version numbers, it means the environment is ready. Next, we use a single command to install OpenClaw globally via npm. This allows us to run the OpenClaw command from anywhere in the system. During installation, you might see some warnings, but as long as there are no errors, it's completely fine. Once the installation is complete, we run OpenClaw version to confirm that OpenClaw has been installed successfully. If the version number is displayed, it means everything is working properly. Finally, we execute OpenClaw onboard to start the initial setup process. This step will guide us through configuring OpenClaw so it can be used in our environment. At this point, OpenClaw begins its initial setup process. First, it will request confirmation because it is running in the terminal and may access system-level resources. Since we are working in a controlled local environment, it is safe to select Yes to proceed. Next, we select the beginner mode. Here we choose Quick Start, which will automatically generate the configuration for us. This is the recommended option, especially for beginners, as it avoids manual setup errors and enables everything to start up quickly. Finally, we come to the step of choosing a model provider. In this example, we have selected Anthropic. If you already have an API key and want to use cloud-based AI services, this option is suitable. Each provider here represents a different backend model, so your choice depends on whether you prefer local deployment or cloud-based access. Next, we will complete the core configuration of OpenClaw. First, select the authentication method as Anthropic API key. This is the most standard authentication method for calling the Claude model, more stable than the temporary setup token, suitable for long-term deployment, and can directly connect to the official interface. Then enter the standard API key starting with skant. This is the core of identity verification. Only when the key is valid can OpenClaw normally call the Claude model service. You can apply for the corresponding API key on the platform of your choice. Next, keep the default model Claude Sonnet -4-6, which is Anthropic's main model for balancing performance and cost. It can handle complex tasks without incurring excessive costs and is suitable for daily use. Finally, choose to temporarily skip the channel configuration and complete the core function integration first. Regarding the selection of the search provider, simply choose Skip for now, Skip for the time being. Then comes the skill configuration stage where you select No, do not configure immediately. This is the recommended safe approach. Skip the skill installation first to avoid a lengthy initial deployment process. Wait until the system is stable and then add the skill modules as needed, which will be more efficient. Next, we enable the hooks option. We choose Skip for now, Skip for the time being. Hooks involve advanced settings such as starting scripts and file mounting. For the initial installation, we keep it at the default setting to simplify the deployment process. We will need to enable it manually later. Now let's look at the installation of the gateway service. Since the service already exists, simply select Restart the service. This ensures that the latest configuration takes effect, allowing the OpenClaw core service to run in the latest state and avoiding conflicts caused by old configurations. Finally, there is the robot startup method. Select Open the Web UI, open the web interface. This is the most intuitive operation method. Subsequently, you can manage the robot directly in the visual interface of the browser, which is simpler and more user-friendly than command line operation. Now that the OpenClaw environment has been installed, let's proceed to use it. First, we enter the folder where the camera course is located. This folder contains related knowledge points and operation procedures such as camera invocation, image recognition, and face tracking. In the current path, we directly tell OpenClaw to let it learn these knowledge and code in this path. OpenClaw will automatically identify the knowledge points and interaction logic, and convert the code content into a skill structure that it can understand and execute. After completing the learning process, you will find that the system will automatically generate a skill package specifically for the camera, along the path of instruction execution. It's like when OpenClaw acquires knowledge, it can then combine and arrange the learned knowledge to achieve any function we desire. Next, we will use the same method to generate the skill packages related to sensors. We switch to the file directory of the sensor course, where the practical code for various sensors such as temperature, infrared, and ultrasonic are stored and have all been implemented. Just tell OpenClaw to do the job for you. After the learning process is completed, the system will also automatically generate a skill package specifically for the sensor. From now on, OpenClaw will have the ability to control the sensors and cameras on your Jetson, and you can let him help you achieve many interesting projects. Now I have a brilliant idea. I want OpenClaw to help me create a case that combines a camera and sensors. I will tell OpenClaw to generate an emotion recognition function for me. All the remaining work will be done automatically by OpenClaw. It will automatically call the previously generated camera skills to capture the face images, automatically call the sensor skills to read environmental or posture data, automatically integrate the logic, write the code, deploy, and run it. You don't need to write a single line of code. You just need to sit by and quietly wait for the final result to appear. The prerequisite is that you need to clearly tell OpenClaw your requirements. Next, let's take a look at the results achieved by OpenClaw for the aforementioned functional requirements. Isn't this awesome? Let's take it a step further and try combining multiple sensors to see if OpenClaw can leverage all of them to achieve the functionality we want. Just like before, all we need to do is write out the functional requirements in detail and tell OpenClaw what to do. After that, it will independently carry out every step as per your requirements, and you just need to sit back and check out the final result. Here, what we want OpenClaw to build is a snake game, which will utilize all the hardware on the Jetson board. Let's check out how it works. OpenClaw is absolutely amazing. For our final test, let's see if OpenClaw can create a small web-based game using Python, and let us control and play it using the hardware on our Jetson. I just had a spontaneous idea, so I'll quickly describe it to OpenClaw and see if it can impress us again. Unsurprisingly, it has perfectly fulfilled our functional requirements. Let's check out the results together.